Welcome, I'm Bill Wake. We're here working on Betwist. It's a word game where you can twist the board around and see a few extra words that way. And today we want to look at the idea of, well, am I on the right day? Yes, okay. I said partial credit. No, I'm not on the right date. Okay. Let's see. Today we're going to look at, let's see, performance. And the reason is we put in a recursive search for every word in a board, and it runs slowly. I left it running, and it took about 2.5 to 3 hours to find all the words on the board. I'm glad it found them. It found lots of words I didn't find, but that's a little slow for us. So we'll deal with performance today. Okay. Oh, I guess I have more to say here. All right. And so one of our ideas, well, one of our questions was, what if we did some sort of thing with the prefixes of 4-letter words? And so I ran this little script. I guess we'll go into it. The awk, the first thing in the slashes is a pattern, and it says, starting from the left, you should see at least 4 characters. If I put a dollar sign, it would be exactly 4, but now it's at least 4. And if you see it, print the substring of $0 is the line. I think 0 is the starting column and 4 is the length. So print 4-letter words. Then I did sort, which is probably unnecessary because the dictionary is sorted to start with. And I said unique minus C. And what that does is if it sees the same word or the same 4-letter prefix twice in a row, like tran, T-R-A-N, transfer, tranquil, whatever, it'll see several in a row, and it'll put the count in the first column and the word in the second column. And then I sort them by numbers, and so I can see the least and most likely ones. And so the least side, a bunch of things starting with A, and the most side, well, inti for integrate and integration and interval and all that, or over, we shall overcome, override, all those. So there are about I think it was 17,000 4-letter prefixes. And we talked a little about maybe we could like categorize, basically do one of these things where you take the list of all that qualify, like a group by kind of thing. So turn this into a dictionary that's the key is these 4-letter things, and the value is a list of words that you could search. And then it's like, oh yeah, we could do a binary search. We're doing a linear search through our 250,000 words. All right. And so a linear search on average then is going to have to go through 125,000 words. A binary search cuts it in half every time. So 16 bits is 65536. So 17 bits is 128,000 and 18 bits is 250, 260, something like that, thousand. So our set of words fits into about 18 bits. And so since the search works 1 bit at a time, we'd expect it would take about 18 searches instead of 125,000. All right. And it's like, oh yeah, that might be a good way to go. All right. And I took Programming Pearls had a nice implementation, and I just copied that and sort of semi-transliterated it. And we'll have to do other stuff to get it into Swift, but you basically start with your lower outside the bounds and your upper outside the bounds. You're looking at an array of 0 to n-1. And then while there's still, while lower is not equal to upper, sort of, then you go to a midpoint, mid equals lower plus upper /2. And then you're going to look at the thing and decide, am I less than or lower? You think there'd be an equal case. I guess at the end, you've squeezed it as much as you can and you check. The result is upper, but if you got out of range or it's not equal, then it's -1. Okay. So I think what we'll do is we'll make this work for our prefix and our word search contains, and we'll hopefully see this thing speed up quite substantially. I mean, well, let's maybe do a little test first, a performance test. So I think what I'm thinking is we'll generate a selection of a random 1,000 words from our dictionary. I don't know if that's enough. And do a search for each one and print the result. How long did that take? If that seems too quick, maybe we'll go 10,000. But yeah. And then at the end, we'll compare after we do the binary search. In my mind, it's kind of a foregone thing, but it's worth it to check a little bit. All right. So I think we'll start there today. We'll just make a test and run that one test for performance test. Okay. And I think, vocabulary, well, yeah, we'll make one vocabulary test and then throw it away. Okay. So, we want our full dictionary, and that comes in at our app, which I don't think is up. Whoop. That's not what I want. Betwist app. Okay, we do this. Vocabulary loader. Well, I'm going to just cheat away and copy this in and put it in our test. Okay, static function load generates a thing. Oh, we don't have bundle? Import foundation. Okay. We load them, and that gives us a vocabulary. Okay, that should be fine. Okay, and this is performance test. Okay, and we're going to let random words equals, well, yeah. Let's take, let's get our vocabulary loaded first, I guess. Let set equal load. Self.load. Okay, and so I'm going to take less than 1,000, so 1,000 words. Dot map, and then nothing in. If you limit the dictionary to words that start with the initial letter, yeah, we definitely could do some stuff to make it even faster. The other one is the binary search. Conceptually, it's sort of one, well, I don't know if it's literally the fastest, but if all you have is a comparison less than or equal, or, less than and equal or something like that, it's theoretically as fast as you can get using that. But there are other searches that use the structure of the keys and the structure of the words you're searching for and make you go faster. Radix sort in particular is one, but we can kind of, like, instead of doing the midpoint thing, we could take the letter at that position, take its ASCII, like subtract capital A from an uppercase letter, and it'll be in the range 0 to 25. And instead of divide by 2, we could take that letter's position divided by 25 and try and get approximately right. So if it was T, the first letter was T, instead of starting right in the middle where M is, probably, we start, whatever T is, 80% through, and maybe we're in the T's at that point. Now, some letters start more words than others. Q is in there early and Z is late, but it would give you a better approximation than halfway. Okay. And it may be that, like, dividing the whole dictionary into multiple dictionaries, one per letter, might do even more. It would make that first letter, we'd have to test that first letter, but then it would go. But my guess is, I think we have very low hanging fruit, because 125,000 searches to get your average one, is more than 1,000 times more than a binary search at all. So, okay. Int has no, well, this should be range, right? Is that going to work? Okay. Yeah, I'm not done yet. Let's take sut dot words sut dot words dot random element. Bang. Okay, we know there's more than one thing in that word list, otherwise our test will blow up. And so I'm populating the list of words. I'm just grabbing 1,000 words at random from the whole thing. Okay, and then I want to print the date. I don't even know what you do these days. Date. A date value initialized to the current date and time. Okay, let's see if that works. All right, and then at the end, we're going to print date again. Okay, and what I want to do is 1,000 lookups, and really that's just contains. Okay, so we're just going to call contains 1,000 times. If it's not true, I guess I want to stop, but I don't even think I care. If it finds it or doesn't find it, I think it's okay. All right, so now let's do 0 to 1,000 dot for each, and I hope this still doesn't optimize it out. Okay, but let's do sut dot contains random words sub I. Yeah, I guess I should be a little more explicit. No, I think I will generate result. Let's start with bar result equals true. And let's say, well, no. Found. And let's do result and equals found. Well, let's make this 0 and count them. Result if found. We'll add 1 to result. Okay. So at the end, we've this and should be 100,000. 1,000. Okay. Load the words with random stuff. Get a result. Print a date. Look them up. Count the pounds. Print the date. Okay. Now this test, I hope it takes a visible amount of time. Otherwise, we'll just raise things to 10,000. And the clock doesn't start until it prints the first date. I should probably print start in there too, just to make it more clear. Okay, good. That's a measurable amount of time. It's not very fast. Okay. 9.3 seconds. Well, let's take all this. I guess that's enough. Okay. Before changing to binary, linear to binary search. Okay. And then let's disable this test while we're working on it. Dot disabled. Okay, so now, well, this is one of those interesting algorithm TDD things. I did look, and I thought maybe the algorithms library, the Swift algorithm stuff, might contain a binary search. I didn't see one. There was some other kind of search that maybe we could adapt, but I think we'll just run with this. Okay, now how do we want to TDD that? I don't know. I mean, we're kind of doing a drop-in replace algorithm. The comparison is interesting. And maybe that's enough. I mean, this is giving us the index of a resulting value. Okay, so I'll just take this. I don't know. What do you think? I mean, we could define something with something low below the midpoint and something above and something at the midpoint. But I mean, this thing needs to go down, down, down to terminate. So you kind of have to have everything there. All right. And in a way, well, our test has very small vocabularies for testing. And that's the biggest one we have. But it should pass, and it's checking all these. Wait, sus has prefix east. Why is that false? Oh, there's no longer word. Okay. Yes. All right. So I think we'll make a contains test. Contains can find any word in list. And let's throw in some family, I guess. Brother, father, mother, sister. And I think I'll extract these and we'll just run through those. Variable. Words. Don't need this. Okay. And then let's do words dot for each word in okay, is that gonna do it? Okay. I think that's kind of a minimal test. I don't know if there's a compare like that. I mean, this algorithm doesn't really use it. It just uses less than up until the end and not equal. So it really just is comparable, I think. Okay, good. that test passed. All right. Yeah, let's plug the algorithm in that context, and I think we'll make it file private. Binary search word of string. We'll make it yield. Is there any point to the index? I mean, contains can do the logic if we return the index. Yes, func. Okay, and then I'll take this. Less than target. Good name for a search target. Lower equals mid. Upper equals words dot count. Okay. Well, this feels like the hard way. Okay. Result equals upper if result greater than equal to n, or yeah, well, okay, so it returns -1 or the actual index. Return result. All right, that's a starting point. This is already defined on string. This is already defined on string. So I don't think we have to actually do anything with that. So instead of words contains words, we're going to do the binary search, and we're going to return binary search of word is not -1. I could say greater than or equal to 0. Okay. Now, will that pass? Now, I think it was this one. John Bentley is the author of Programming Pearls, and oh no. Okay, we got one that did not be happy. Turns out it's a oh. Huh. That's our random sample thing. In 100 letters, it returned more K's than E's. 5, it must be 6. Okay. I'm going to make this even looser. This is false flagged a few times. I mean, we have like 10 E's for every K in our list, so it's a pretty unlikely thing. All right, that all passed. Okay, let's run our performance test and compare performance before and after. Okay. And I don't know, I might leave that in there commented. We'll just run the one test. I'm guessing it's less than 9.258 seconds. Yeah. Okay, 0.117. 2542. Okay, that was within its margin of ticking. Okay, so what is that faster? So sort of like times 10 would get you to 1.1 seconds. So it's about 100 times faster. All right, let's record this. That launch thing, I don't know what that is. I'm not going to keep it in there. Well, that's one of those Xcode bug things. Okay. And then I'm going to put, I took it out briefly, this text all answers. I'm hoping this happens nice and quick. And so let's do a run. Hey, we're creating a Boggle game. It's sort of an imitator of Boggle, and then it's a word search game. We have the notion that you can wrap around the board and get more answers, and we have a bigger grid. And at some point, I'm going to go to 6x6. But okay, so here we're timing. How long does it take to find this board? This may be a minute. This is obnoxiously slow. I also wanted to count how many lookups we do, because this is a real performance thing. So last night when I did this, it took 3 hours, 2.5 or 3 hours. I was hoping it would be 2 seconds here, because at the end of the game, you want to just say, hey, what did I miss? We'll see. Yeah, could add a third check. Yeah, I think I'll keep it the way it is, because in Programming Pearls, he took a lot of trouble to kind of prove his solution out. And he talked about, like the first one that demonstrated the algorithm was wrong, had bugs in it. And it took them years to get a bug-free version published. His version, interestingly, a bug was found in it, and it was when I think when they went to 64-bit machines or something, there was some situation where you could end up with a value that was bigger than, because somewhere you're adding +1, you could end up bigger than the 64 bits, and something would go wrong if you had a very, very large, a large limit. Perhaps do 10,000 to limit the overhead from the printing. I don't know. I mean, well, let me do some, we did some breaking yesterday. So if I stop here and I'll print the, oh, it won't help prefix. We need to generalize that to help prefix. Okay, well, I'll print this for interest, but this is prefix. Okay, so he's up to PUE. We don't know what letters he's got to work with, but I can turn this off and continue. And actually, I think I want to look at the binary search one, and we'll print word. Okay, so the way our search works, this sort of means that PUTAT is probably a valid prefix, and then it tries to extend it with every letter around it. So putative is a word I can think of meaning supposedly. PUTATR, I don't know that that's a word anywhere, but we will turn it off and continue a bit. So notice it was PUEEE. Oh, I don't know. I'm kind of willing to give it 5,000. Do 10,000 to limit the overhead from printing. Well, it's not thousands of words that are in the board. It's more like thousands of situations it considers. I'm really shocked it's this slow with the binary search, but I do know it's also calling has prefix, and that is also a linear search. So we should generalize our binary search to a generic closure that determines whether it's satisfied. Now, I don't know if the list of 4-letter starts is helpful. I mean, this is... Well, it's contains, right? And this one is contains, where 0 starts with prefix. Yeah, that's a little tricky, isn't it? You can't really search it the same way you could find the word that started that had that value, but the prefix is a little trickier. I guess if the word matches, I can see my CPU is cranked out. If the word matches, we don't really know because he's always looking for something less. So what he's doing is this squeeze halfway, 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 and then when lower and upper are one away, then he knows he's down to one thing. And if it says that upper, so I guess if it's upper, if it's the original upper words.count, then upper never moved. So we've searched, maybe we have A through L, and we searched a word with T, and the index is going to be after that range. But this, we should limit the length to check the max length of letters in a word starting with that letter. If there isn't a word longer than 7 letters with P, we should end the check at P. That's a good question. Yeah. Okay, let's break there again and see what word we're up to. Watt P. Okay, so I mean we got a different letter involved. I mean factor of 100. So what's my, well, 3 hours is sort of 200 minutes, give or take. So 2 minutes should theoretically be enough. Would only save one round. Well, that's the thing, because we're checking the prefixes, right? So, has prefix. Well, let's see what we are doing. Words contain something that starts with prefix and not equal to prefix. Well, I mean, we could look beyond. I mean, we get the. Oh no, we wouldn't find it. Oh, that hurts. Okay, yeah, that's tricky. We need something though, because clearly it's still doing has prefix at the slow rate. And I don't know, maybe it was spending half its time in contains and half in has prefix, and now it's only going to be an hour and a half. You know, that's a little long for our 2.5 hour coding session. But we need an algorithm. Only contains words with the starting dictionary. Well, how does that help the prefix situation though? And that sort of helps the first letter situation, but I mean the problem is, okay, let's go back to the algorithm again. If we're searching for a word that's not there, so let's say we have treasure, we got TREAS is the prefix, and we would like to be able to extend it. So we look for TREAS. And we're trying to find, are there any words that start with that? And that's not really exactly less than. Well, again, if we're only doing the starting letter, right? It's only going to help once. I mean the well, let's look at our recursive search. I think that's in game. Yeah. Okay, so if it has a prefix of selection guess, then we try the extensions. Okay, so yeah, so okay, I guess my concern is vocabulary is this is a linear search. I think we can define it. So if you get to the end, well, let's say you're looking for the four-letter word, something, you're looking for that four-letter word. Okay, we've got over, and we're trying to find out, should I keep going? Are there words that start with over? No, let's take a different one. INTE, okay, is not a word. So we'll search for INTE, and I think what happens is we word submit less than target, we lower. Okay, if it's not there, but at some point word submit maybe it's greater than or equal to target. I think somehow we're going to locate the location where it should be, and then at the end we're testing, is it really there? But I think the moment of truth is kind of here. If words the result is not target, then we're going to fail it. And yet we don't care if target is in there, because INTE is not, I don't think it's a dictionary word. And certainly if it is, there's some that aren't. I think we're going to have the index where it should have been if it was there. And at that point, we should be able to look at the next word. And if the next word starts with it, then it's there. It's a prefix. If the word is there, it's no problem. It'll find it. But this conclusion, I think we can do it from the outside. Right, but well, I mean, you definitely cut down. Yeah, I mean, you're cutting down by a factor of 26 in effect, right? I mean, you would have on average 10,000 words per thing. Words like S that have big sections in the dictionary would have, lots of words, and words like Q and J and Z and X would have a few. But okay, I'm gonna try and replace this. I think we asked the question. Let's see what we ask in here. Contains, I think that was the sorry, is that this one? Has prefix. Okay, and we're trying some that are and some that aren't and stuff like that. So let's see what we can do. All right, so I guess my argument is, I guess what I'm saying is I don't like this. Because I think when you get here, result like upper at the end here is the index where it should be, and if it's not there, then it's not in the dictionary. But in our case, if the word at upper, well, I don't know whether it comes in. I'm not sure how to go with this. All right, so I think what I want is this. So this stuff is not helping. Okay. Now I could move that down here. I'm going to extract method instead. Okay. Can I extract method with the tool? No. Okay, I'll copy. This is index. Target of string, yield an int. Okay. Return upper. Okay, so that should be the equivalent of let result equal binary search index of target. Excuse me, var result. Well, maybe we just care about the Boolean at this point, but I'm just refactoring, so I'm being very pure about just extracting stuff. Okay, and we're still running. Okay, we given it, I don't know, 20 minutes. That's plenty. I definitely won't wait that long. Okay, right. So now binary search index, I believe, contains, where should it be? Whoops. Let index equal binary search index of target prefix. Okay, and now there's sort of two possibilities. Either the word was found if the target, if the words at index equals the prefix. Let's take that case first. If words at index equals prefix, okay, then is this a prefix? Well, we just found the first occurrence of it, so we want to look at words index plus 1. Let's see, prefix starts with, okay, so if it's there, it's got to start with the prefix. Okay, if word sub index plus 1, well, if index plus 1 less than or equal to words.count and word sub index plus 1 dot starts with prefix, I think that's true. If the next word does not start with the prefix and it was found, we're returning false. Okay, and then we got the case where we didn't find the word. Okay, but we've got the index where it should have been. Okay, and so if that's that case. Otherwise, we're in the else case. The word was not found. The prefix was not found, and we're going to check. I guess I want to say if. Well, if word sub index dot starts with prefix, okay, then we'll return true. The problem is I don't know whether it's at the index it wants or not. Okay, I'm going to comment this a moment. Otherwise, let's say return false. that assumes if you find the place where it should have been, it should be less, right? Okay. Let's try this. I think there may be a case for index plus 1 here too, but okay. So we will run tests. Now, I don't know. In a way, it feels like a kind of, I call it argumentative solution. Yes, you don't like my spacing. Okay. Because it's pushing these things. Okay. And let's make sure our test covers the cases. Okay, so has prefix EAS. That word is not found. Okay, let me add some cases. I want to expect the system does not have a prefix for easy. Because there's no word that starts with EASY except easy. So I'm assuming in that case, it's going to find nothing. Okay. Because it will find the word, but the next word is not does not have the right prefix. Now the other case, okay, sorry, another case. Let's make sure that we do not have a prefix for zoo. So I'm going to try and go off the end of the list if I can. Okay, we already did one that's at the beginning, but let's do one that's after the end. Okay, it doesn't have a prefix for west, zoo, so it doesn't have the word zoo, anything starting like that. And let's also check west. Again, I'm trying to kind of force it off the end and check my boundaries kind of thing. All right, and so the third case, did we cover it? Okay, so this one, if we find the prefix, but we don't find the next word with the prefix. Okay, I think that's fine. And then this one, we start with we found the word. And this should be index plus 1. And okay, let me keep that. I did that for east though. Yeah, so on the east one, I'm checking a word that's before the first word, and this one I'm checking a word that's after the last word. Yeah. I guess I should, whoops. Oh, yeah, that's what I wondered. Okay. We have index plus 1 is out of range. I don't know which case that is. Has prefix testing north. Okay, so why are you failing there? Oh, this is the case where you found the word. This is the case where you didn't find the word. Okay, so I was thinking backwards. Okay, so you don't find the prefix, then I think this should be index. I think index should be where it would have been if it were there. Okay. And yeah, the question to me is it finding the spot before where it should have been or the spot after where it should have been? Okay. let me just quickly in my head do a one case. So if I've got a list of one word and I search for the word bat and I search for the word at, okay, my upper bound is 1. My lower bound, it starts at -1, and my value is 0, is the only valid word. 1 minus 1 plus 1 is 0, is not equal to 1. Okay, so we take the lower plus the upper. Lower is -1, upper is 1. 0 divided by 2 is 0. Word sub 0 is less than target. Yes. I'm looking for at when I have bat. So lower is mid. So the lower bound is now 0. Okay, we go around again. Lower plus 1 not equal upper. Lower plus 1 is equal to upper. So we stop. We have 0 as the index. It should have been. Okay, so it's at the next word. Okay. So let's run that again. Make the equal prefix a guard. Yeah, I think I want to do this. If the index plus 1 is less than is greater than or equal to words.count, there's no way it's a thing. And then we can just return this condition. And okay, wow, boy, it tells you what arguing does, doesn't it? Let's find which test. Wait, what are we? Had prefix. Okay, let's see index. Let's see what prefix is. Zoo. Oh, this is my outer case. Okay. So I deserve this problem. Okay. So word sub index is 4. 0, 1, 2, 3. It's 4. It is greater. Okay. Oh. Okay, so the index is already out of bounds here. Okay, that tells me that clause should have been up there. Okay. So index is equal to words.count. Zero, 1, 2, 3. It should have been at 4. Okay, if the index is out of range, we just didn't find it. And certainly even if we did, then it was the last word and there's nothing after it anyway. Okay, so I can take out this condition. And this will simplify things. And then I can just return this. Okay, I think if the word subindex starts with prefix. Okay, so this is it was found. This is it not found. Okay, and then I'll keep this separate for a moment while we make sure we're solving these. I know it's a tricky thing to work with an existing algorithm like this, and okay. Let's see what our words are. Index 0. Words A. Oh. Oh, this is all answers. Okay. Index is 0. Words.count is 1. If word subindex equals prefix. Okay, so we found the thing in there. then at that point I'm at index plus 1. Index greater than or equal to words.count. Index is 0, words.count is 1, so it's not greater than or equal. I guess I got to know if index plus 1 is greater than or equal still. Yeah. Okay. If the word was found, well, I'm gonna make it ugly and then make it better, I guess. Okay. So now we're checking the case at hand. We found the word, but it's the last word in the dictionary. And we want to know if the next word following it starts with the same prefix, then it's still okay. But if it's the last word in the dictionary, we don't want to do it, and it's false. Otherwise, if it is found, then that's a good thing. And we know it's not equal because word subindex is equal. Okay. And let's see why the test here didn't catch that. I guess maybe it didn't run that test first. Let's just run this test. I know it's hard to think through these little tweaky cases like this, and to make sure I've got that covered. Okay, so that feels good. That's with the change I just made, though. Well, if index is greater than or equal to words.count, right? That was the original thing up here. If result is greater than or equal to words.count, it's not found. Okay. But I guess it's only in this case, if we found it, then we have to worry about index plus 1 because we want to look at it. This case, we did not. Okay, in this case, we did not find the prefix standalone, but if the word we did find has that prefix, we're good. Okay, I really don't want to introduce a subtle bug here. This is where I'm not as confident on the algorithm side. If it finds the thing, we returned 0 before. Okay, so 0 is the first slot before. Is that before the end? My @bad example, we returned 0 for @, but there's no word there. @ is not there. But if it is a prefix, if @'s the prefix, then we'd be okay. Okay, so I think I'm better. Let's run the whole suite. I mean, the tests are definitely saving us here for sure. But I feel like I should be able to do something. Yeah, I guess. Okay, good. But in this case, I don't think I can escape this test because if the last word is the prefix, we search for zoo and that's the last word in our dictionary. We don't want to say it's a prefix of something because there's nothing after it. So we found zoo, but there's no zoology in this dictionary. Okay, so if it's too big, then we just can't find that word. Otherwise, we found the prefix and the next word starts with something, it's good. Okay, I believe that. Now this one, if the word we found, the index we found, starts with a prefix. So we were looking for INTE. We found integrate or integral. I can pick one that's less. We found integral, and it starts with the right word, the prefix. Then that's good. Okay, so I'm going to try and flip this. Just return that value. Whoops. And now I don't have to mess around with that stuff. Okay, that should have been a pure refactoring. It either started or it didn't, and okay. All right, now I want to re-enable our performance test because all tests worked. Okay, and just run this. Oh, that was contains. All right. Contains. And this one will be has prefix. Dot, was it substring? Oh, starts with prefix. I forget what you have to do to get a substring. Substring up to but not including the one to get an index. Well, I'm going to take the deprecated one for now. Substring to up to but not including. Up to but not including the one to give an index. So I guess 5 to 5. And the result needn't be 1000. Okay. Let's run this one. This is the current search. Oh. Cannot convert int to expected type string.int. Can I do array slice? So is that allowed? No. Subscript has been explicitly marked unavailable. Okay. Prefix. Do we have it? Yes. Okay. Max length 4. Yeah. It's funny, the little corners you never remember. Okay. Except for one small problem. I think he's still reporting the old one. I don't think it'll ever reach the starts with check. The index starts with 1. Are you talking about this one? Or cannot convert value string? Okay, so this has to be string. Yeah, I was afraid it had to do something like that. Okay, let's run this test. Has prefix. And then I'll put it back the old way for a brief moment, and then Now, unfortunately, I'm doing prefixes in the loop, so it's a little slower than it might be. Okay, but that was pretty quick. Okay, so this is kind of after. Okay, we'll take this code. I don't know if this is a warning or an error if I just do this. Warning. Okay, let's run that same test. Has prefix. Okay. And before it was like 10 seconds, so hopefully something similar-ish. In has prefix. The index starts with 1. I'm not quite seeing. Now, I don't know if it's actually running yet. The array index starts with 1. Are you talking about this index? It definitely, the search definitely assumes it's got an array of 0. Okay. I mean, it's starting at 0. 48 words contains. Index starts with 1. Well, he doesn't really know. He assumes he's got the prefix first, so he doesn't really care about the length. It doesn't have to be 4 or anything in particular, right? We check any given word. But whether this is running or not, I don't think we're there. Sorry, 47. So words of index. Index starts with I. So this case is the word is not, the prefix is not found as a word. Okay. But if the place where it should have been, like we're looking for east, well, let's go int and integral again. So we're looking for inte as the prefix, and the word after it is integral. It's going to not find inte, but I think it's pointing us at integral. And that word has the right prefix, so he's not the prefix, but he starts with the prefix. So I think that's okay. I can't argue. I'm absolutely sure on this now because I've been wrong too many times today. But this is weird because the first thing we do, we generate those words, and then we print the date, and we haven't printed the date yet. So it's like we're not really running. I mean, as far as I can tell, we haven't put these in either. I'm going to stop it. I'm going to run this test again. And I'm still the bad way, right? The old way. Okay. Like, he should be getting to this line really quick. What's going on? 2. Does that mean there's 2 things running? Indexing paused. The warnings. Yeah, that's fine. I just don't know if giving it another 30 seconds helps or not. Thank you. Yeah, I always fail to consider that possibility. I don't think we've had to do it before on this newer version of Xcode, but yeah, let's just do all 3. Okay. We'll run this test. Well, let's start right there so we can see that the test even been doing. How long for Swift? Gosh, several years. I know when I started doing this in the pandemic, I remember doing a Swift one pretty early, and I know I'd used it, played with it a little bit before then. And then the first project I did took about, I don't know, it took months, maybe a year. And that was not Swift UI. So I've mostly been using Swift UI since then. Okay, so he thinks he's starting testing. Somehow he's not getting to this line. Yeah. This is weird. I mean, 1,000 lookups isn't that much. But I don't think it's doing anything. Is that's still there? He doesn't actually show anything because he's just a container to run those tests. Let's look at, where's the CPU one? He's buried. Oh, I know what it is. It brings this up even though you're not using it in the background. So I think that's what's going on. It's slowly running our slow version of that thing. Okay. And I think I'll just tell it to run all tests. It should stop when it hits our new test. Yeah. Okay. And we'll just continue from this. I think I have a breakpoint down here. Yep. That's okay, breakpoint. I think I bumped it. Okay, it's running. All right. There's our first print. Has prefix 1915. Okay. So 34 seconds. And then I'm going to take this out again. And run those tests again. So has prefix is even slower than the other one, because the other one was 10 seconds. Well, 9 point something for 1,000 words. 10. Yeah, 9 something for 1,000 words. This one was 10 something. I guess I just deleted the one I wanted to save. All right, let me take it back out. Sorry. I wanted to give it 35 more seconds to get the numbers. Run the test. Okay. So 16 seconds. Okay, and let's clean this out and see if it works. Okay. Run. Well, I'll run test just to make sure everything's good there. Okay, good. And I'm gonna disable these two tests. I think that's just generically the best for now. I mean, they clearly aren't that slow. They take a third of a second, but they're the slowest test. Okay, and then we'll run. Oops, that was test again. Oh, then I'll put content view back to the problematic thing and run with an R. And hopefully we can see this thing. Come on, be fast. Faster than that. Okay, that's a little slow, but it's not impossible. Yeah, it depends completely on the board. Okay, I'm not going to look at the answers. Oh, I changed it after each one. Ooh, that's bad. Okay, I should have just done a print somewhere in the beginning. But I see snake. I don't think it's snake eye will quite work. But, I mean, look at all these words. Elegized, wongied. Okay, I might have heard of elegized, but I know I have not heard of wongied. Shagets. Yeah, I just don't know what they are. Now, where... I don't know where that leaves us. It's taking too long. Okay. Elegizes. All right. Boy, there's a lot of words here. I see 3-letter words. I thought we filtered those in our dictionary. Okay. I mean, there's a lot of words. Snakeweeds. Oh, my goodness. Okay. And the idea was, after you did the game, we would show you the words you missed. And it's like... Oh, you're so good. You found 20 words. I've got 175 for you that you missed. I might filter this like words 6 or longer. Selenate. And I'd like to know the longest possible word. Teosinte. Wow. I do not know some of these words at all. Actually, most of those words at all. Not, is that the saying none early on? Teeniest, that's pretty cool. Yeah, I really don't care about every little 3- and 4-letter word. but we can tweak that. Vengeance CNS. Hello. All right. So we're working on this word search game. It's kind of like the commercial Boggle, but we just added this thing to walk through the board systematically and identify every word in a very large dictionary. And it does a quite intense job, but it is also relatively slow. So after I hit a letter, it's going to take a little bit of time. Yeah, you don't get to, yeah, that'd be nice. Give you the meaning of these words. I mean, well, SDEIGNE, I have no idea. Okay. I don't know if I'm only, is it as long as it's gray there, a second? That's not so bad. It's just a touch long, but yeah, I don't know. And that word's not in there. Yeah. Let's go back to the beginning and we can see it consistently. And that's a lot of words. But I mentioned before, I have friends that when they play, I think they don't count 3-letter words. They don't count 4-letter words. And they don't count 5-letter words that all you did was add an S, like heads. Telegones. I don't know. They play pretty intensely, but I got to think even they would be daunted by finding these words. Okay, so let's go back to snake. And these words are in no order at all. They're just kind of whatever order they got found. All right. Boy, that first one is just too slow. I mean, it's almost bearable, but it's just a little too slow. Oh, Lisa. Okay, nice to meet you. Okay, now maybe printing them, it may take a little time to do that. What can I do here? Because this is really supposed to be once you've solved it. Well, maybe I shouldn't say it that way. Our thought was once you've solved it, we show you the list of these are the words you got and these are the words you missed. That's a lot of words to miss. And the other thought we had was, hey, if we've already gone through the dictionary and we have all the words that you can make, then all we have to do is keep that list there around as our dictionary now, because for this board, it's the only words that count. And then our play would be instantaneous, but our play was already okay even with a super, super slow search. So I don't know where that leaves us. Well, that word counts. Okay. That pause is just enough to feel too awkward. I don't think that pause would be as annoying at the end of the game. We could put up a little computing sign or even a little animation of flashing very random letters in sequence or something while it does it, to make it kind of bearable. All right, let me kick off a new run. All right, and I should say we're working in Swift and we're doing TDD to some extent. Today we did a sort of pre-built algorithm and we had some TDD around it, but not itself. Well, that wasn't so bad. That wasn't. Let me do that again. Still seconds. 1, 2, 3. Yeah. And that doesn't include. That includes printing them on the screen, which definitely takes a little time. Let's try and put it in. There probably are. I mean, there's a lot of words I never heard of in that dictionary. We have it here, yeah. I mean, you kind of like scroll randomly and point at the word, and it's like starwort. Okay, I don't know. I mean, I would kind of assume it's a plant. Um, you know, statesmanship. Okay, that screen's all right. But there's a lot of words I don't know. I mean, most of these are steamy with an IE. You get words like that or like alternate spellings. Is an old form of disdain. Wow. I guess I'll have to remember that. I don't think I use a lot of it. I don't use disdain that much, but stain. That's very cool. Um, I mean, they don't strike me as non-words too much. I mean, there was like not. I think that's kind of, I don't know. That sounds like a sort of obsolete word to me. Um, Meaning, oh, it has nothing to do with nothing. It is something about cattle. Okay, the northern. Oh, it's a Northern English pronoun meaning nothing. Okay, that was more like what I was thinking, like UGHT. Okay, but my wife works with oxen sometimes. She was learning to lead an ox team and stuff like that. She may have heard that for that. Neat cattle. Okay, so I mean that's a little bit of an Northern English pronoun. It's probably not a very common U.S. word. Noxel, I don't know. Noxies, all these others though, they're kind of okay. I mean, it definitely has lots of obscure words. It would be nice in a way, like, wow. It would be nice to maybe run the list that you get back through some sort of filter that could tell you that, or, you know, words found in, with more than 100,000 occurrences in Google or something. um, I mean, I've never heard this word. Some sort of something. Naked gills sea slug. Okay, how many words? Oh, Google or yeah, I use DuckDuckGo usually. Well, we'll take this over to Google. No, I don't need maps. Okay, don't they tell you how many results anymore? Wow, I hadn't noticed. Okay, I mean they got at least 10 pages. Okay, so I mean somebody's using this word. People in the Seattle area, I guess. Um, hmm. So, all right, let's do this again. One more startup. It's 1, 2, 3, 4. Some of that's 5, 6, 7, 8, 9. And what did I take out? Oh, that was with it gone. Okay. And we're not computing it. So that's just the normal startup with Xcode. It's sometimes faster, sometimes... Oh, it had to do a build. Okay. Well, that's... All right, let's just kick it off here. All dictionaries has the word. Okay. Oh, now that's very fast, isn't it? That's how I should do it. All right, let's take this, put this back, run it once, and then start it up on the simulator directly without Xcode involved. Come on. How do I do that? All right, so now my click as a user on the simulator, a second-ish. I can't select those. Okay. Well, yeah, I'm trying to click home. I guess I could do the keystrokes for it, right? Yeah. Okay. That's almost tolerable. There's probably a way to put a startup screen on there that maybe makes it less visible. Although also that depends on the words, the board. But we're finding, I don't know, a couple hundred words maybe. And I'm seeing 3-letter words. So that tells me I thought we had made our dictionary shorter and filtered those out, and maybe we haven't. I have the house above the simulator. Oh, this one. Oh, okay, cool. Thanks. It's good to learn these things. Okay, so we take out those small words. I think that also may have some more effect because some words that look generatable disappear because these aren't prefixes of them. Or maybe... Yeah, I think that would do that. All right, let's take that out of the dictionary, see if we get a sort of a feel of a different amount. Well, game. All right, right now game owns minimum size. I think maybe we need to know that going in. Okay, so I'm gonna bring up our initial app. Okay. So we still might be calling prefix with 1 or 2-letter words. Filter. The word count is greater than or equal to game.minimum size. It's probably minimum word size, but okay. Let's run again. So we should see a lot fewer words in here. Yeah, this is a slow start. Oh, did I? Okay. Well, that certainly did not win and set any records. I don't see any 3-letter words. I thought we had done it too. Let's go to vocabulary. Nope. I guess I don't need that anymore. I think we talked about it enough. That maybe that took the place of doing it. Okay. So that felt slower to me to start up though. So let's do the home thing. Take this out and run it just locally. Yeah, that's about the same. I don't think I felt a difference. Now, I could believe for the benefit of the game, it might. This I just can't tell. Like, should you have to find 5-letter words to be worth it? Because I feel like I spend a lot of time clicking around. Clicking around words like this. It's like, it's never, it's a short word. It's in there. That's great. But it doesn't really, I don't know. I feel like I'm working for this and not for whatever I want to do. Finding those little short words, because my real thing I'd like to do is go for longer words, but I take the short ones. Sometimes the short one can get you, can get you the idea for a long one. Wow. Oh no, it's CAOPHONOUS. Nice word. I wish I hadn't seen it here and found it anyway. Okay. Well, I don't know. Is that too slow of a startup? I guess that's the question. Your first time. Well, that's a little too fast because it was already running. Yeah, now the funny thing is, for me, when we did it before with the slow search, when it checked a word, it did not feel that slow. It was definitely sub-second response. Well, this is a second-ish for the whole list, not just which is checking a gob of words. Okay. Because you got GUAV. I could get guava. So the prefix looks good because guava's in the dictionary, but I do guav-E, guav-W, guav-T, guav-H, guav-F, guav-X. And that's kind of the case for everything. And especially these short ones, they all seem like any 3-letter word in the dictionary. I'm sorry, any word in the dictionary that starts with GUR is a good candidate. Yeah. Well, we have a speed above quite a bit. If it's 1 second versus 3 hours or 2.5 hours, 150 minutes is 2.5 hours. So 20 times 150 is 3,000. It's a substantial speed up, and I'm glad for it, but it's just a little, well, I'm not going to show them between each click. That's for sure. I don't know if this is a spelling of fraught. Nope. And even here, I find it a little like I want to type faster than that. You can generate the shorter dictionaries on the form. I filter the full list just to try it. Yeah, I guess the other one I wonder is, I wonder if maybe this this 4-letter list that was kind of like well, let's do this again. Is this clickable text? I think I put a carriage return in there somewhere to fit on the screen. No? Okay. Yeah, I did something. Control A. Get rid of this 2028, whatever that is. Okay. That's the 4-letter words. Let's just unique them and count them. Okay, so yeah, 17,000. Now, on the other hand, like we load up 250,000 words and it doesn't take that long. I was surprised that was even fast enough, much less going through the board. Um, like we could, let's get to the game. So our recursive thing here, like we could ignore the has prefix if the guess is small. I mean, like, why do we run through the dictionary to check that O is a valid prefix of every word? You know, it's just um, not likely to be a problem. All right, let me try that. Um, I'm gonna say if prefix dot count is less than 4, return true. I don't know if this will work. This is definitely a spiky kind of thing. But I'm saying let's just assume they're in there. Why do we look up all the initial 2-letter, 3-letter things? Because most 3-letter combinations, you know, there's pretty good odds they're going to be in the dictionary. I mean, 17,000 out of 250,000. Oh, that felt fast. Okay. Yeah, that was still slow. That's still slow. Okay, which it's rerunning it every time, so we don't need to do that, but it's just a guide. Um, okay. Well, I can't say it does. It may have made it. Yeah, generate the shorter dictionaries on the fly. Fell to the full list. So you're saying one dictionary per letter or per prefix? I don't know how fast it is to get a letter from a string. And the sort of end point of doing what you're suggesting is tries, however we say them. Um, yeah, let's get pictures. And they basically take the prefix. You're sort of getting a prefix tree out of the words. So normally, I think there's a flag, like they get a double stripe if they're actually a word or something, if they're partials. Um, so pot is a word, past, pass, part. You know, you only get to the leaf ones, but par should be a word, so I think that should have a flag, you know, a flagged cell. Oh, this one's nice too because you don't have to go one letter at a time. Well, T. Oh, okay. You like if you had a innovate. INN is a word. INNOVATE is a word. You don't need the whole tree in the middle, one letter at a time. You could just do in, and then innovate, and then innovated, and innovator. Generate the short dictionaries, filtering the full list. So I want to make sure I'm doing what you're suggesting. Oh, we should take a break before we do it. But are you saying 26 dictionaries or 17,000 dictionaries or what do you think? And I guess an alternative would be don't do the binary thing, do the estimate the distance thing. But um, I'm kind of wanting to group by whatever makes sense. I even had looked that up somewhere here. Is it this one? Yeah. There's a init grouping by. You can make a dictionary based on those. Okay. Yeah, let's try that. It'll be a nice experiment. Um, take a break, 3 or 4 minutes. We'll come back and start in on that. I don't know if that's a 45-minute solution or we'll have to go into tomorrow to finish checking it, but it's worth it. All right. See you in a few. All right, welcome back. How to get the first character of a string? Is that string.first? Does it give you a character? String prefix gives you a string. Sub-0, is that a character? All right. Okay, so split the dictionary once. Create a map using the first letter. So you just should we just do a dictionary? This dictionary grouping thing should do that for us. Let's let prefix to words be of type string to string, string to array of string. Okay. So this is kind of a parallel change refactoring is kind of what I would say I'm doing. So I'm just going to do it and see what happens. All right. So that other article I had was probably going to do it. Dictionary grouping device array is the thing being grouped. Okay. By device goes to string in return device.category. Okay. Two words equals dictionary grouping words by well, let me try that again. I just want grouping by. No. Oh, sorry. I don't know. This seems complicated. Device to string. Maybe word is what we're getting. Word, yeah. Okay. And then contains word is well, I guess we're going to have to pass words in, right? Target string in words is array of string. And same thing here. First I'll put it like it was. Okay. And then contains, whoops, contains, we're first going to get well, let's just do it in line. Okay, so it's what do I call it? Words to prefix? Prefix to words. Words. Sub. Which one is it? String. Okay. Is that true? I guess we're guaranteeing every letter is in there. Yeah. Okay, let's just do the one and see if this works. And actually, we could just re-enable our tests and see if it's looking faster. Oh. Found nil. Oh, wait a minute. What's word? BACD. That should be a B. What? Oh, it's a test. Okay, what's he doing? Validating illegal words. Okay, so this is B. Well, okay, that's kind of artificial. Oh, wait a minute. No, our vocabulary is one word. Okay. All right, I guess it's going to have to be or nothing. So you're searching an empty list if you don't find anything with that prefix. But in our real usage, I don't think that's going to happen, because the dictionary does have a word that starts with each letter. Okay. one issue. That's that other change I made. Okay. Let's take this out. Yeah, the test does not have that structure with a word for each letter of the dictionary. So, okay, and let's run. We've only done half now. And the fresh start is the one. It might be a touch faster. Okay, let's run our little performance test. We just did contains, so we'll just, whoops. I don't think it'll run it because it's disabled. Yeah, skipped. Okay. Okay, so it's got to be noticeably faster than 116 to be worth it for us. 178. Okay, let's do it again. $177. Okay, that's comparable. What do you want? Yeah, I don't think it's coming up as being substantially faster. All right, let me. I was very remiss on checking in earlier. We got a lot of changes. Let's pull. Well. I guess the change in this one is basically words. If I just pass in the words, it's a little change, but it's not a big deal. And I'll comment this one out. I think. Yeah, let me do this. I don't think we're using it anymore. Okay. I'll leave a little junk in, but I just want to get we've got a lot of changes that seem like progress. So let's check them in. Okay, and then all right, I'm gonna have to look at these changes even. Well, okay, so we added the binary search. We also I think our whole search thing was in this check-in. So make vocabulary to binary search. Make make a full search for board. Look up all potential words or find. Okay, and then let's do some tweaking on this to see if we can get it fast. Did you not check in? Push. so contains, no. Yeah, we did contains. Oh, okay. Time to beat was 116. But I think we might be able to find some faster ways to handle this. Yeah. We can raise that. I mean, 0.116 goes to 1 point. We'll make it take a second to give it 10,000. 10,000. 10,000. Duplication. Okay, let's run this test. This is the previous, the way we started. Well, not quite started, but it's the binary search, but it's not the split up dictionaries. Well, did I not run this test? Well, that felt pretty spiffo. 0.113. I guess that's similar. Oh, well, that's good. It's the old way. Okay. So yeah, that should be similar to 0.116. Let's take this back in. But wait a minute. It should have been one. It should have been running 1,000 more. Count 1,000. Something's not doing something. Did I edit the wrong test? Yes. Okay. All right. And I have this not in place. Okay. Let's run this test again. Yeah, first time I ran the other test, I don't know, disabled test, and then ran it with the wrong number of elements. Okay. Well, that's still... .127. Well, maybe we're not over the threshold yet. Maybe because before it was so, so dramatically different with the original stuff today. Let's run it for 100,000. We got to get it long enough to feel it. Okay, count. And count. Okay, because it's easy in performance stuff to run. If you run too small a test, you're running in sort of the noise level, and apparently that's what we were doing there. It's like, that's just how long it takes to run a test, 0.127. And still, it's just barely bigger, right? I mean, we can't even see the difference in our clock, which is suspicious. All right, but let's go up again. So, I'm sorry, we'll make it 1,000,000. Okay, I noticed it. Okay, so that's one tick, 1.196 seconds. Okay, and that tells you that's about what the board was, right? So that tells me the board's probably looking up about 1,000,000 possibilities. because that's about what it felt like was a second to reload that. Maybe a little off, but okay. Now we can do our test, and I think we'll see a difference if there's a difference. Prefix to words, that's this one, and that's the old one, and back to the test. Okay, 1.196. It's interesting to me. Date apparently is putting zeros for all those sub-second things. Okay, 1.374. Let's run this a few times. Okay, 374, 384. 1.47. Okay, so I mean, as it stands, I don't think we're seeing substantially better, and it's it's consistently a little worse. I don't think we've done everything we can do to make this fly though either. The thing I wonder about. I wonder if we made it work on characters instead of strings. Now our strings, I don't know if we always did uppers or not, but I don't know. Does it? Well, I think part of it is. Well, I think it's like, what are we paying extra, right? We're paying to build up the dictionary in those pieces. We're paying a space penalty because we have the map and separate string arrays. So that has overhead for each thing. That's kind of one time. But the space overhead can affect the time overhead. And then we're taking these word prefixes all the time. And especially for contains, right? The prefix we're pulling out a prefix of a string which is already complicated compared to like C. The copying of the dictionary when calling the routines. Theoretically, the dictionary should not be copied because it's a let. So it should be able to detect that it's not copying anything. And actually, and they tend to use copy on write. So if you changed it, that would affect it. But I don't think it's being copied. Only other than the first time, What else could be? Well, I'm wondering about that this prefix. So if you were doing this in C, you'd have an array of char, and accessing that array of char takes, one instruction to get the character out, and then you've got a byte sitting in there somewhere. In Swift, right, a string is a relatively complicated beast, because it allows for Unicode and UTF-8 and all that stuff. So pulling out a character is not like pulling out a byte. They're not fixed length bytes or anything. I mean, in our dictionary they are because they're all letters, but in theory. And then we take the prefix. Well, that builds up this substring thing, but then we turn it back into a string. So we have to build a separate one with string with whatever count or whatever string does. Actually, they probably, I'm pretty sure they build up another little structure that says, give me the substring, from character 0 to character 0 inclusive. And it's a little piece, a substring thing. You don't have to do prefix once. Yeah. But I'll tell you what, I think let's try, I think the result of this is a prefix, a subsequence. Okay. Yeah. Let's take this string off. We can get rid of at least one action here. It should complain. Okay. It should tell us what it wants. String.subsequence, aka substring. Okay, so let's make this thing be a substring, and that'll get rid of some string conversions. Word.prefix 1. Okay, where's the other one? There. Okay. Right, so that takes the little substring object. I hope that's hashable and everything that it needs to be, but now we're not rebuilding a new string that wraps around it that knows it has a substring. So it's definitely going to cut out some complexity. Okay, we had 1.37 to 1.47, something like that. All right, let's try it again with that. So we've modified this. And I think that's more or less as good as we can do. I don't think we can just like give me the first byte. Maybe we can. Sorry, run the test. But on the other hand, a million string creations is not, I mean, it's a lot, but it's not that many. Okay, it took a little off, 1.41 instead of 1.34. Oh no, I'm sorry if it does. I can't tell on my side, honestly. It's saying drop frame 0%, so I don't think it's anything bad. But I mean, I'm living in North Carolina, and like all kinds of people are having problems with power, water, internet, and all that. Ours seems like it's been okay, but what are you getting, Mud Shark? Been fritzy, huh? I don't know. I wonder if it's, I don't know. I mean, like my CPU seems relatively on track, and like I said, 0 drop frames. It's saying between 400 and maybe 700 KB per PS, which seems in my, I get 4 little green bars, which is a good thing, but yeah, don't know if it's anything on my side. If it is, I don't know anything I can do for it either. And so maybe something between there. Oh, sorry. Yuck. All right. I do, well, they catch the recordings after if it's really obnoxious. And then I eventually get them posted on YouTube in a week or two. But those are coming right from my side, so it's as good as I get anyway. All right, 1.453. Yeah, I think we're just maybe a little better, but it's just not substantially better. Now, I don't know. Okay, 393, that's the best we've had, I think. Well, no, we had 378 once. Okay. All right, I have another experiment. Let's do this, but we're going to do 3 letters and see how many of them there are. Because I have a feeling like bad short words must use a lot of resources. 35. Okay, that's okay. I guess that's reasonable. It's smaller than the 4 letters. It would have to be because 4 letters are built out of the 3 letters. I mean, I wonder if, like, if we took this list, um, let's do this. Unique minus C, we'll get the count, and then sort minus N minus R. We'll put the top ones at the top. It's almost better without it at the top, isn't it? Okay. So, oh, nice. Yeah, so like over was our biggest 4-letter one, so OVE is pretty big for the threes. But I wonder if, like this list, I would take the numbers off, but if I just put these in there, like we would have a list of the valid prefixes, 3-letter prefixes. And I think I feel like in the game algorithm somehow we should be able to use that fact. Like, so I'm thinking to modify has prefix to, if we said it all has any 2-letter prefix, because almost every one is in there, right? I mean, there's no JXs and JQs and stuff, but well, maybe it's not. Okay, so, well, what's 26 cubed? I mean, 26 times 26 is like 5 something, right? And this is 70 times, no, 500. This is 7 times that. Because we could do the same thing for 2-letter sequences, but I got to think we got most of the, quite a few of them in there out of the several hundred possible. But you don't have a lot of, you have a little weird consonant combinations that might not qualify. Okay, so 359. All right, so out of, well, what's 26 times 26? I should know that. I'm thinking 476. I don't know. Let's see what we get. Should end in a 6. I know that. 676. Okay, so of the 676 2-letter combinations, we use 400 of them, which is about more than half. Maybe 55% or something. So that tells me that 2-letter combinations won't filter very much. 3-letter combinations, okay, there's 17,576 possible. You'd filter 1/5 of the potential words out. Okay, so I don't know. Is that right? 5 times 3,000 is 15,000. Yeah, maybe 1/6. Because I could see taking our prefix, kind of like here, we could say has prefix. If it's 1 or 2 letters, we just say yes. Okay, it's like I'm just going to assume all those can make words. But now if we restricted the 3-letter ones to this list of actual 3-letter ones, we would cut out, we'd cut by a factor of 5 or 6 the number of potential words we were trying, rather than, well, yeah, because has prefix is working pretty hard to check 3-letter prefixes when the answer is no, 80% of the time. So this would be a faster way to get that 80% answer. So I don't know. I mean, in a way, fixing this, generating fewer possibilities means, like, because the way, it builds up from things. So it definitely has a chance of reducing the search space before you even get going onto these longer words. I mean, if you got 20%, hmm. I guess if I'm trying to think, if you restricted 3-letter words, let's do a run. um, I feel like you would lose a lot of words because you're trying, um, where you're killing off stuff before it gets too long. But I don't know, maybe 3 to 4 letters isn't like PDD. There's no words in the dictionary that start PDD, I'm pretty sure. PED, yes. DEP, yes. DDP, pretty unlikely. I was surprised by Stain. So would blocking out 3-letter words faster? Well, I guess the thing is they're calling prefix. Yeah, okay. So if the way we do it now, a 3-letter word has to do those, 18 searches on average to find, to isolate its word. And maybe it's only 9 or something, half it. But, it's doing some number of searches to isolate its word. But if you searched in a much smaller list, a list of 3,500 instead of a list of, sorry, how many was it? Yeah, 3,500. Do a quick adjustment to let 3-letter guesses through. Well, they, I guess the thing is you're blocking. What are you doing? You're saying, I'm going to search 3,500 words. Okay, so what's 3,500, right? 2 to the 10th is 1,024. So 2 to the 12th is 4,096. 2 to the 11th is 2,000 something. So 12 checks instead of 18. Okay, so you'd save 6 checks per potential word. Yeah. So okay, yeah. So if it's half the checks or something, well, that's start checking. That's kind of what I did before briefly, and it didn't seem to make too much difference. But I don't know if it. I guess when I think of the way this goes, right, like I start doing prefixes of things, WEH, like in my mind, I don't know any words that start WEH. We'd have to go to the real dictionary to find out. But this is a pretty big dictionary, so like maybe there are, and I just don't know them. WEE for sure, WEF, WEI. Hey, okay, yeah, there are no WEHs. But like we still find that out early now, right? Because we go WEH, are you a valid prefix of anything? And he goes, no. I guess the question is, how many times do you get a 3-letter word? Well, okay, that's a good experiment. That how long are the words you're searching for? In contains, at least, or in partial prefix. Let's see, that's vocabulary. So I think I'm proposing what we do is instrument contains and keep track of, well, maybe we keep track of all the words that get done. I mean, it's going to be slow. We have to put them somewhere. We could count the lengths of the words that we get, and then that would be an array in here, and the max is 100 or something. I mean, we got a 5x5 board. I guarantee the words we're finding are not longer than 25. And like, obviously we must be searching a lot more 3-letter words than 17-letter words, because we're only searching 17 letters if we had a 16-letter prefix. So I would guess we're searching, the 6 around it for each one, and then we find out like, no, there's no such word. But maybe instrumenting it like 3 versus 4 might be very interesting to know, or 4 versus 5 or something. So yeah, tomorrow let's instrument contains and has prefix. I guess we'll wrap this in something to count it. But I would like to know, how big of words are you checking for this thing? Maybe we just need to do contains. Actually, count the number of calls on each one would be a step forward. That's an easy start tomorrow. How many times do you call contains to build our board once and find all the words? And how many times do you call has prefix? That would be a good thing to know. And then maybe do the by word length and see if there's 1 million calls total and 900,000 of them are to 3-letter words. Well, that seems unlikely, but but I would know, wow, there's that many, it's worth optimizing 3-letter words or 4-letter words or whatever. The other possible things, well, we're searching. I mean, the words in our dictionary, we can check that this is true, but they most likely are mostly A to Z. There may be a couple, punctuation things in there or something. I don't know. O'Shaughnessy as a name has a quote mark in it, Maybe there may be something we can do there. We're also paying string prices, Swift string prices, full Unicode support and the whole thing, for something that at least in English can be done with ASCII and can be done actually. 26 letters. How many bits do you need? 16, 32, so 5 bits would be enough. Maybe you put them in a byte and you don't pay a penalty for accessing offset bits or anything. That could be a good way. The other way is super clever. I'll mention it briefly because we're out of time. But this was done on the early version of spell check in Unix, and blanking out on what you call them. But what you do is you take your string and you hash it into some space, and you check the bit at that hash point. And what you do though is you hash it like 5 different ways. Okay, so you run 5 different hash functions on your string, and for each dictionary word, you take that word, you run the 5 hash functions, and it tells you 5 places to put a bit, to set a bit. And you get sort of a probabilistic answer that says, like, if I ran 5 random hash functions and it found those 5 bits set, then this word is probably a word. If there were only 4 set, it's probably not a word. Well, it's definitely not a word. Okay. But you could have some that are not words, but they hash to the 5 bits are set, or 10 bits or whatever it is, but, they did that and put the dictionary in a very small space. And it's a very quick thing to do because you're just doing these little arithmetic computations, especially if you just had a set of bytes. So, there are definitely paths from where we are to much faster word lookups. But because of the sort of exponential nature of the grid and matching things, if we could find a way to cut down that grid first, that'll save us. So it gives us something fun to look forward to. We're almost there. If this were running in 1/10 of a second, I wouldn't even think twice about it from here. So we're getting there. We shaved off, a factor of 200 or 500 or something. That's worth it. All right. I'll be back tomorrow, 2 to 4:30 Eastern Time, 6 to 8:30 p.m. UTC. Mudshark and Cat, me and Linda, was it? Thank you for joining today and speaking up, and hope I see you tomorrow or some other time. Have a good evening. Bye-bye.